previous classes, you have learned that motion is of different types. For example, when an object changes its place, it is called displacement motion. Some objects rotate around their own axis. We call it rotational motion. In the third type, object moves forward and backward along a path. We call that vibration motion. In displacement motion, the object can move in two ways. Sometimes the object moves in a straight line. This is called linear motion. And if the object moves from one point to the other on a curved path, then it is called a curvilinear motion. So, displacement happens in two ways. If you see, here is a glass of water, and it is tied with a twisted string. When the twists become loose, the glass starts rotating along its own axis. Water from the glass seems like moving away from the center and upwards, and a depression appears at the center. We call it a vortex. How is this vortex formed? When any object is in circular motion, it tends to move away from the center. The force acting on it is the centrifugal force. The object is thrown away. Here, the rotating water tries to move away from the center, but is stopped by the glass walls, and so it moves upwards. At the center there is less water due to the outward movement, and so a depression can be seen. If we tie a stone to a thread, and you rotate the stone with the thread around your head, then you feel your hands get pulled. As soon as you remove the force of your hand, the force on the thread ends, and the stone will be thrown away. The stone is thrown along the tangent to the circle of rotational motion. All this happens due to centrifugal force. But then, many of you may think, if the planets in our solar system are rotating around the sun, as stated in Kepler's first law, Kepler has stated in his first law that planets in the solar system rotate around the sun in elliptical orbits. You may think why they don't get thrown out. Like we have kept the water enclosed in the glass, it does not get thrown out of the glass. Or the stone tied to the thread has force acting upon it by our hand, and so it does not fall from the hand. So why are the planets moving around the sun? We have to say that there must be some force which is acting against this centrifugal force. This is called centripetal force. Kepler had not realized this. When Kepler gave his three laws, this force was not mentioned. Later, when Newton studied all this, he realized that Kepler had not noticed this. You have read some mention of this force in 9th standard. Newton thought that this must be gravity or gravitational force. And due to this gravitational force and the centripetal force, these planets in our solar system revolve around the sun in different orbits.